So let me go ahead and share that screen. Okay, so I'm going to do something a little unusual. The stuff about strings it's pretty shoot, I don't know the word for it. It's not really conceptually difficult. It's pretty, like 80% of it is really just like, okay, here's a list of functions you can use on characters. Here's a list of functions you can use on C strings and so on. This is the one time during the semester when I'm actually going to lecture pretty much just like straight from the textbook. And we're just going to go through the chapter and I'm going to point out a few things, and that's going to be pretty much it. My idea is I think we may actually make it all the way through the chapter today, and I will start on next week's stuff on Wednesday. What we basically have going on here is we are warming up to the main event. So we're going to start on classes and object-oriented programming, not next week, but the week after. And so I'm basically kind of trying to cover anything that we're going to need to know going into that, so that when we hit it, we've got all of the background information we need and we don't get stuck because, you know, we didn't understand something about C strings or something like that. We can really focus on the object-oriented programming. So 2 more weeks, including this week, 2 more weeks of warm up. So what we're going to be talking about is characters. And so these first two sections here, basically mostly just a list of different functions you can use on characters, an intro to C strings, a bunch of functions you can use on C strings. That's 10.4 and 10.5. Oh, wait, no, that's just 10.4. 10.5 is some functions related to the string class. And then some more about the C++ string class down towards the end. Okay, so with characters, basically all this is, I don't think this is anything that's gonna be new to you other than just maybe the names of the functions that are available, right? So you have to # include CC type. And then you've got all these functions you can use: is alpha, is alnum, is digit, is lower, is print, and so on. You can imagine that is print is probably not the most used one. What you're going to see a lot of is things like is lower, is upper, is alpha, you'll probably use, is digit, you'll probably use. And then just to see an example of using those functions, here's some code. We get a character, and then we just check to see which of the categories it falls into, right? If is alpha, that's an alphabetic character. If it is digit, that's a numeric digit. If it is lower, and so on. Any questions about how to call those types of functions? Okay, I do have a couple of random thoughts that this has brought up for me that I'm just going to throw out there. One is, you'll notice that, so you can tell by looking at this include statement that these functions here, is alpha, is digit, is lower, and so on, those are inherited from C. The way you can tell that is because the actual name of the class is C type. So if you were writing this in C instead of C++, you would say # include C type .h. But when we are in C++, instead of including that .h file, which is a C include file, we use CC type. So this first C here is C++'s way of saying this is a file that, this is an input file that we inherited from the C programming language. The other thing that is interesting and related to that is that these functions technically Let's see what he says here. See, it says returns true, and then in parentheses, he says a non-zero number. So because these are inherited from C, C did not have a such thing as a bool type. So at least back in the day. So instead of having these functions return a bool, they just return, technically, they just return an int, 0 for false, non-zero for true. But the idea here is that we just ignore that fact, right? We just assume that these functions are returning bools, and we treat them that way when we are writing code in C++. Any questions about any of that? Okay, more code you can look at in the textbook later. I'm not going to go over this example. Just another example of calling those character testing functions. Okay, next. So we're going right through here, right? We've got what, 7 sections, and we just finished the first one. Section 2 is just about converting, oops, sorry, I just moved chat. Those functions already exist. They are inherited from the C programming language. That's going to be true for everything we see in this chapter. That's why we say # includes CC type. Those functions are written in the C type, in the CC type header file. So if we don't # include CC type, then we can't call it. Okay. Oops. All right, so character case conversion. Basically, this whole section is just about these two functions, 2 upper and 2 lower. They return the uppercase equivalent of the argument or the lowercase equivalent of the argument, respectively. There must be a way to just make the controls go away, at least temporarily. Anyway, I'm afraid they won't come back. Okay, there's a few little details you may need to know about that. Actually, you know what? Let me try an experiment. Let's actually write this code in a program. Just bear with me for a minute here. See out to. Okay. Oops. Okay. Anybody want to tell me what I'm missing here? Correct. Yes, I'm going to need to say # include CC type. Now let me, this is a digression, but let me just mention that often your program will actually work if you forget to do the # include. So let's try it. So I'm just curious, because often these # includes are included in the other header files that you are including. The problem is that that's dependent on the system. So you definitely want to go ahead and # include CC type, even if your program happens to work when it's not there. just because maybe if you try running it on a different system, it won't work. Or if you, even if you like flip the order in which you do your pound sign includes, maybe it won't work. So it's always best to just always pound sign include anything that that you need to. So I'm going to try it first with it there. Oops. Okay. Is that what we were expecting? Nope. Right. Okay. Anyone want to take a shot at what's going on there? Why is it 65? That's right. What's happening here is that technically, and again, excuse me, this goes back to the fact that these are C functions. So instead of returning a char, technically, what they're returning is an int. That is the ASCII character for the char, right? So if I want to actually get my A here, I'm going to have to convert it to a char. And this is not the preferred way of converting to char, but I'm going to leave it like that for now because I don't have the proper way memorized. Remember how when we're doing the random numbers, we did the static cast thing. That's the preferred technique, but this will work for us for now. There we go. There's our uppercase A. Okay. Again, for the most part, even though these actually return an int, we treat them as if they're returning a char. That works in 99% of the situations we're in. It's very rare that we're going to actually just like print the results of a 2 upper or a 2 lower. But you just have to have that in the back of your mind in case this comes up sometime. Okay, that was fun. Couple other details we need to just go over. You can put any argument you want here. It doesn't have to be a lowercase number. Lowercase letter. If you put something here that's not a lowercase letter, it basically just ignores it, right? So it's going to return the same thing. The return value is going to be equal to the argument if the argument is not a lowercase letter. Same going the other way with 2 lower. If the argument is not an uppercase letter, it's just going to return whatever the argument was. Okay? I'm kind of surprised that he does this because that's actually not accurate, right? We tried this and it doesn't actually print the lowercase letter. But anyway. All right. Oh yeah, one more thing students often get confused on, okay? This is a good illustration of that. What's happening is not that we are actually changing the value of letter, right? After I call 2 lower and then I print out letter, it's still uppercase A. Okay, so what's happening is not that we are changing the argument. What's happening is that we are returning the lowercase version of the argument. Okay. Another way of putting that is the 2 lower function, in the 2 lower function, the parameter is passed by value, not passed by reference, right? So there's no way for us to actually change the letter. Okay. All right, so there's a program here that just illustrates some of this stuff, but I'm going to leave that for you to take a look at on your own time. Just take a look at it, make sure that you're not missing anything and all the code makes sense. I don't think it'll be too tricky. So this chapter is, I'm always struggling to find the words to explain what I'm trying to say here, but basically it's just information, right? It's not like it's explaining a complex concept. It's 99% of it is just, here's some information you may not have had before, just in case you need it, just to get us ready to dive into object-oriented programming, which will be more interesting from a conceptual perspective. Okay, so I think that's all about characters. Let's talk a little bit about C strings. Can't remember if I know we've talked, I think I've at least mentioned them in passing a couple of times, but it seems like I should just start as if you have no idea what a C string is. So before C++ came along and we just had C, strings were all what we now call C strings. At that point, they were just strings, that's what they were. And the way that C strings are stored is it's just an array of characters with a null character at the end. Okay, so hopefully we have a picture here. Right, so here's a C string, Bailey. Here's how it's stored in memory. All of the characters. This is an array of characters. And then the way that C++ knows where the end of the string is it looks for this null character. A null character is, if we wanted to actually just put one in our array manually, sorry, I'm hoping we have that symbol, but I don't see it. We would just put a \0 in single quotes, right? Just like if we wanted to print a new line character, we would say, we would put a \n in single quotes. Here we have \0 in single quotes. We'll see an example of that in a minute. And that's our null character, okay? All right, so that's how it's stored. We haven't actually seen any code yet. The other thing you need to know is that in your C++ code, when you see a string literal, let's scroll down again just so we can see some actual example in a program, right? So here's a C++ program, and here we have a string literal, right? So even though that's a literal, C++ is going to have to store it someplace so it can print it. When it stores it as a C string, not as a string variable, not as a string object variable. Okay, so that's just a little interesting trivia that may come in handy at some point. I'm going to digress just for a second here and make sure that I can't remember if we've talked about this before, about the fact that we've got two different ways to represent strings in C++, right? We've used the string class a little bit, not a lot. And we've used C strings a little bit, not a lot, but we're going to be talking about them more in this chapter. That's what we're doing here. But just to emphasize that there's two completely different techniques for storing strings. And so my point here is sort of that when you see a string literal in C++, well, how is it stored? Is it stored as a string object, or is it stored as a C string variable? And the answer is it's stored as a C string, not as a string object. And again, that goes back to the fact that we inherited all of this from the C programming language. Okay, let's see what else I want to say about this. All right, let's just look at some more examples. Any questions so far? Everyone doing okay with this? This is kind of weird that you can ignore this cell over here. It's not actually supposed to be there. This is supposed to be two completely separate examples. Okay, so The C programming language does not provide a string class like that which C++ provides. In the C language, all strings are treated as C strings. When a C programmer wants to store a string in memory, he or she has to create a character array that is large enough to hold the string plus one element for the null character. Any questions about that paragraph? Make sense? And actually, we're going to be doing some of that in a couple of weeks here. Why does this matter to us? We're not learning C, we're learning C++. Here's a few reasons. One, the string class has not always existed in the C++ language. So you may encounter programs that use C strings if you are looking at older C++ code. The string class was introduced to C++ in 1998, if I'm not mistaken. So that would have to be some pretty darn old code. But I would not be surprised that to find out there's quite a bit of it out there still. Some of the C++ library functions work only with C strings. Not sure if I can think of an example of that, but okay, we'll go with that for now. In the workplace, it's not unusual for C++ programmers to work with specialized libraries that are written in C. So as a C++ programmer, it's a bonus if you know how to work with C also. I would add that, well, a couple things. One is it's going to be really useful to understand what's going on under the hood when you work with a string class. That's something that we do a lot of when we're studying computer science in an academic setting, as we want to know what's going on behind the scenes. And also, it's going to be a great way to learn about some more programming techniques. Okay, so you know, part of the point of this list is not just to explain why we're studying C strings, but to point out that in real life, if you're just writing a program and you're trying to do it in the clearest, cleanest way possible, safest, you're not going to use a C string. You're going to use a string class object. So just keep that in mind, even though we're studying C strings. Okay, so here's some code example. Here we're declaring an array of size 21. That means that we can hold a string, a C string of up to 20 characters. Let me stop there for a second. That is super, super critical. I guarantee almost all of you are going to forget about that at some point, and it's going to cause you, you know, an hour of trying to track down a bug in your program. So it's going to be helpful if you can just burn that into your brain. Everyone understand why this declaration right here creates an array that will hold a C string up to 20 characters. Okay, because you're going to have that 21st element of the array, you're going to need that to hold the null character, so that C++ will know that where the end of the string is. Okay, not a space, just to be clear. I know what you mean, but the null character is, oh no, I get it. You're right. You're right. I read your chat wrong at first. The null character needs a place in memory, right? Needs an element of the array. Okay. This is something you normally wouldn't be able to do with a normal array, but in C++, char arrays have some special abilities that other types of arrays don't have. So we'll see a couple of those coming up in a minute, but this is one of them, right? You don't have to worry about putting the null character in here. It's automatically added as the last character. Okay. More details here. You can read about the details. This code is interesting because, well, let's actually just read this here. In the previous statement, name indicates the address in memory where the string is to be stored. Of course, CN has no way of knowing the name has 21 elements. Super, super important. We're going to be dealing with this a lot, okay? If the user enters a string of 30 characters, CN will write past the end of the array. So we're going to spend a significant amount of time working out ways to prevent that, right? This can be prevented. One way to prevent it is by using CN's getLine member function. Assuming the following array has been defined in a program. Okay. Here's an array called line, and there are 80 elements in the array. The following statement uses CN's getLine member function to get a line of input and store it in the line array. The first argument tells getLine where to store the string input. The line is the variable where the string input is going to go. The second argument indicates the maximum length of the string, including the null terminator. Okay, so in this case, size is equivalent to 80. So CN will read up to 79 characters or until the user presses the enter key, whichever comes first. Okay. Important new function. We're going to be using it a lot in a couple of weeks. Any questions about getLine? Okay, let me just point out an extremely important difference that like 3 or 4 or 5 weeks, we're going to be doing an assignment, and the biggest thing I remember about this assignment is that students always forget this fact. So here's another thing to burn into your brain. Okay, the getLine function stops when it gets to a new line character. That's different from the extraction operator, right? Up here, we used the extraction operator to read a string. The extraction operator stops if it gets to any white space character, a space or a new line or a tab. Okay, is that clear to everyone? Any questions about the difference there? Not only is getLine a way to limit how many characters get read, which is sort of how it's being introduced here, but it's also different from the extraction operator in that it only stops when it hits a new line character, not when it hits a space or a tab. So if you're writing a program to read stuff and you want to read a string and you want it to stop when it gets to any white space character, you cannot use getLine to do it. There's just no way to make it work for that. Okay. If you want the reading to stop when it gets to a new line character, but not stop when it gets to any other kind of white space, you can't use the extraction operator to do that. There's no way to make that work. Okay, so just keep that straight. One more thing about getLine that he does not talk about in the textbook, but which we are going to use a little bit, and that is that if you want to make it stop at some other character instead of the new line character, you can include that as a third argument there. So I could say cn.getLine line size colon, and that's called the delimiting character. That's the character that is going to make getLine stop reading. So instead of stopping when it gets to a new line character, it's going to stop when it gets to a colon. Okay, any questions about that? All right. Okay, so that was basically the one part of this chapter that is actually about giving you some more information other than just listing a bunch of functions out, right? So we're done with that. Now what we're going to do is we're going to go over a section in the chapter that basically just lists a bunch of functions that you can use with C strings. I need to time out just for a second here because I realized that for some reason my computer is not charging and it's about to die. So let's just, why don't we just go ahead and call it a 2-minute break, and I will be back in a minute. Okay, so we just finished talking about the introduction to C strings, right? So now what we're going to do is we're going to go through several C string functions that that we can use. I'm definitely going to sort of tell you which ones are going to be important for us in this class and which ones are not. It's the ones that I say are not important for us in this class. I would say, it's possible you might see them on a multiple choice question on an exam, but I wouldn't worry too much about it. Just make sure you know where to find it. The exams are open book. You can just go look it up. And probably, hopefully, you'll have enough time during the exam to do that. So here we go. The strlen function, super important, returns the number of characters in the string. The question always comes up, does that include the null terminator? The answer to that is no, it does not include the null terminator. But I always kind of like to try to talk about that a little more because ideally, you wouldn't have to ask that question, right? Because a function like strlen is a function that is meant for the programmer to be able to use in a sense without really being concerned about the implementation. So when you say strlen, ideally that should automatically mean, okay, that means the length of the string sort of in the abstract sense, right? If the string is hello, I'm not concerned at this point when I'm calling strlen about how that string hello is being stored. I just want to know that that word has 5 characters in it. So anyway, enough of that. Basically, you just need to know that strlen is going to tell you the number of characters in the string, not counting the null character. That's it for strlen. Okay, strcat, definitely important. Going to be using it in at least one program in this class. It concatenates 2 strings. Several important things you need to know about it. Hold on just a sec. Okay, so this is typically considered a function to avoid using these days. We're going to be using it anyway because I'm trying to teach you sort of the behind the scenes stuff. So it's considered unsafe because it deals with sort of raw pointers, and you're going to be having to be very careful about allocating enough memory to store the result of the strcat function. And if you don't, then you're going to have all sorts of strange errors going on. So you just have to be careful when you're using it. In fact, if you're using Visual Studio, by default, Visual Studio will not let you use this function. So there's a special code that you have to put in your program that I provide to you in the assignment where you'll use this. So just be careful when you get to that assignment. Don't forget to put that special code at the top. Okay, so all right, so basically what we've got here is we've got the surcat function is going to take two strings, a string 1 and a string 2, and it's going to combine them together, and it's going to put the result into the string 1 variable. Okay, so here's an example. You've got the word hello in string 1, you've got the word world in string 2. If you call stircat on them, it's going to create, it's not going to change string 2, but it's going to change string 1. So the string 1 is going to be equal to the string 1 plus string 2. So we'll get this output. Any questions about why we're getting that output? Okay. Another thing about stircat to watch out for is that technically speaking, the stircat function also returns the result. But basically the way that you should treat stircat is you should just ignore that and think of it as a void function. All right. Here's the other issue, and this is the most important part about stircat that students tend to get wrong. Okay, notice that we created this first array here to be of size 13. Okay, we had to create this array to be big enough to hold the whole result, hello world, right? If I had just not put the word size there and left the square brackets empty, then the word hello would have been stored in an array of size 1, 2, 3, 4, 5, 6, 7, right? And then when I got here in my function to stircat, I would have been trying to put a string with 13 characters into it, into an array of size 7. Anything could have happened, right? It might have worked okay, but what's happening there, even if it does work okay, is that we're putting characters into an area of memory that we have not allocated. And so it's probably going to be a problem at some point. Often what will happen is your program will just crash and you'll get some sort of a strange error message. So super, super important. Here's the summary, okay? Before you call stircat, make sure that the first argument is an array that is big enough to hold the whole combined string. Any questions about that? Okay, I'm going to back up just for a second because I can't remember if I said this already, but just in case I didn't do this basic definition. In case you have not heard of, in case you're not sure what the cat stands for in stircat, the cat stands for concatenation. That's basically just a big fancy word that we use when we want to combine two strings together. Okay. Any questions about stircat? Here's the big warning, right? Okay. Okay, if there's no questions, I'm going to go ahead and talk about stircopy. I actually find it odd that he covers stircat before stircopy, because in my mind, stircat is sort of like a more complex version of stircopy. I would say, just to give you an idea, I would say stircopy is, the one we're about to study is basically like an assignment operator for C strings. Right, so if you have two C strings, C stir 1 and C stir 2, and you can't say C stir 1 gets C stir 2. There is no assignment operator for C strings. Okay, so instead you have to say stircopy, stir 1, C stir 1, C stir 2. Okay, so that's basically, I mean, we need to talk about some details, but that's basically what the point of stircopy is. The point of stircat is, if we want to say this. Right? So we can't say C stir 1 plus equals C stir 2. So we just say stircat, C stir 1, C stir 2. All right. I don't know if that helped or not. Basically, my idea there is to try to give you an idea of what it is we're trying to do with these functions, right? These functions are basically being provided because C strings don't have some of the capabilities that most other types of variables do have in C++, right? So we have to provide a stircat function because you can't do plus equals with C strings. We have to provide a stircopy function because you can't do the assignment operator with C strings. All right, so here's the, what is the colon on line 8 for? I noticed that. Oh, that was just a random example, but this was saying if for some reason I wanted to call getLine, and instead of having it stop reading the string when it got to the new line character, I wanted it to stop reading the string when it got to a colon. That's how I would do it. Okay. All right, let's talk about stircopy. Here's an example of calling it. Basically, just exactly like stircat, except there's no concatenation going on. You're just taking the second argument and putting it into the first argument. Same issues that we had with stircat. We have to make sure every time we call stircopy, stop, go through a process in your brain, ask yourself the question, is string 1 big enough, or is it the right size to hold string 2? Okay, and apparently in this case it is. And again, we've got this warning of the array specified by the first argument will be overflowed if it isn't large enough to hold the string specified by the second argument. Okay. Any questions about stircopy? All right, so those are really the big three. Thinking it seems like there might be, I think that's it. Those are the big three in terms of the important C string functions. Next, we have a couple that we are not going to be using: stir_in_cat and stir_in_copy. Basically, the idea here is to make these safer. And the way you do that is by providing a third argument, which gives you the maximum number of characters that you should transfer over. Okay. I'm not going to talk about that anymore. It's there in case you need it in the textbook. As it turns out, if you go online and look at what people have to say about these functions, basically they're saying they're not really all that much safer anyway. Why bother? Just use the string class. If for some reason you can't use the string class, you might as well just use strcpy and strcpy. What happens if the second argument is smaller than the first argument? Yeah, yes, that's exactly. Yes, that's exactly right. If it just copies it in, that's fine, and it does nothing at all with any of the other elements of the first argument. That make sense? Okay. All right, what else do we have going on? Okay, stir function is another one that we are not going to be using. Possibly might come up on an exam, so you should at least sort of know where to find it if you need it. I think I'm just going to move right on over it. Yeah, you can take a look at that at some point if you want. Here's our list. Oh, stir compare is the other one that's important. I knew there was one more. Did we skip over stir compare? Hold on. What? Stir. Oh no, it's still coming up. Okay. I'm so confused. Stir. Stir compare. Here we go. Okay. I don't know why this table is here in the actual hard copy of the text. It's after all of the functions. Okay, stir compare. I believe that's going to be our last C-string function that we need to talk about. So the stir compare function, again, it's provided because in C++ you can't use things like equals, or less than, and so on. So you cannot use relational operators, that's equals and less than and greater than, and not equal to and less than or equal to and greater than or equal to. Those are relational operators. You cannot use them on C-string variables. So instead you have to use the stir compare function. And basically the way that works is that if they are equal, the stir compare function returns 0. If C stir 1 comes before C stir 2 alphabetically, like where you would find it in a dictionary, then this number over here is stir compare is going to return a number less than 0, like that. Okay, and you can guess that if it's greater than, if we're trying to check greater than, then you would replace it with stir compare C stir 1, C stir 2 greater than 0. Okay. Any questions about stir compare? Here, let's look at this complete example. Okay, we've got, it's not as exciting as I thought it was going to be. All right, one more thing we have to mention is that stir compare function uses ASCII codes, right? So what that means is that instead of strict alphabetical order, uppercase letters are always going to come before lowercase letters. right? So dog and dog, in this case, stir compare is going to tell us that dog comes before dog because the uppercase letters come first in the ASCII table. Any questions about that? In fact, if I use stir compare to compare dog and anteater, sorry, it's the only animal I could think of that started with A. It's going to say that the dog comes before anteater. Okay, that's going to return a number less than, well, I guess that's not what it should say. That's going to return true. So is it good practice to use expressions like too lower when comparing strings? The answer would be, it depends on the context, right? But certainly if you're in a situation where you're trying to put things in alphabetical order and you don't care about uppercase and lowercase, then it would make sense to use too lower or too upper on everything, just so that you're comparing everything that you're comparing is the same case. Yes, that makes sense. Okay. All right, let's look at the next section. I actually think that I'm gonna go through the next section very rapidly. We're not going to be needing any of this in this class, so you just need to put it in your toolbox, so you can look it up if you need it. Possibly might come up in a multiple choice question on an exam. So here's functions that just accept C string as an. So this section is all about converting C string objects and string objects to numbers and vice versa, right? So if you've got a string 4, 5, 6, 9, a C string, and you want to convert it to an integer, A to I is the function to use. Okay. Not going to go into a lot of detail on the techniques here. If you ever need to do that, you know the options here. You can come back here in this chapter and look it up, or you can just Google it, of course. ToString is the opposite, right? Take an int value and convert it to a string object. So it's just going the opposite direction. And I think that's all I want to say about converting numbers and strings back and forth. Okay, and then the next section is about writing your own C string handling functions. Turns out that's actually what our next assignment is going to be having you do. I'm going to be having you write functions that manipulate C strings, but without using strcpy and strlen and all those. So you have to do the actual low-level manipulations yourself. So I don't think there's anything too much to look at here. It's just some more examples of using the stuff we already know. You should definitely go through it when you've got a few minutes. I will say that for whatever reason, if you see code written in industry that's using C strings, very rarely is it done using array notation with square brackets. you access the elements that way, but it's usually declared using a pointer and using dynamic array, so using the new operator to create the array. So you should get used to seeing char star a lot. Okay, we're going to be seeing a lot of char star. So this program is just an example of passing C strings using pointers and pointer notation instead of using array notation. So if you go down here, you can just see there's my parameter. It's a pointer, but as we know, this is exactly the same thing as if we had said stir pointer with square brackets after it. Any questions about that? Now, I would say, I would recommend not using pointer notation when you're actually accessing the elements in the array, just because array notation is so much clearer most of the time, right? And basically what we're doing here is we are using pointer arithmetic, which there's nothing particularly wrong with it. I guess in my opinion, I would probably try to avoid it and just use indexing into an array instead. I think that would be simple. All right. So not much. Let's just see what is going on in our next section. So this is the last section. Is it? Yeah, the last section in the chapter. Just more about the C++ string class. So have the # include the string header file. Declare variables of type string. Assign variables of type string. Notice that technically speaking, this on the left side is a string object. This on the right side is actually a C string, right? Remember, because in C++, whenever the compiler sees a string literal like this, it treats it as a C string. So what's going on here with this assignment operator is there's a conversion going on. Before I can do that assignment, I'm having to convert that C string literal into a string object, and then I'm doing the assignment. You can print out string objects just using the insertion operator like usual. Pretty sure we've done that. So here's maybe the key sentence, right? C++ has basically tried to make it as much as possible so that strings are just like working with variables of other types. Unlike C strings, you can use assignment operator, you can use less than or and greater than and equal to, you can use plus equals, all of those operators that you could not use with C strings, you can use them with string objects. In answer to the question about, so is it that it's not as easy to see what index you are using, you are on using pointer arithmetic? Yes, I would say that's one thing. Honestly, I'd have to think a little bit more about my rationale for what I just said about, in my opinion, using array notation is typically just clearer what's going on. I mean, that's not, I'm not gonna like draw a line in the sand on that one. That's basically just my instinct. I'll have to think a little bit more about why I would say that. Okay, reading a line of input into a string object. So we have getLine, but this getLine is really different from the other getLine we were just talking about earlier in the lecture, right? In this case, there's no CN in front of the getLine. In this case, it's on a line by itself. The first argument tells us where we're reading the string from. The second argument tells us where we're putting the string. Okay. in this case, we don't have to worry about name being big enough. But so backing up just a little bit, the big difference between between these two versions of getLine is that the previous version of getLine that we were looking at, the argument was a C string. So it was when we were reading a string and putting it into a C string variable. This version of getLine, the one that doesn't have the cin dot in front, we are reading a string and putting it into a string object. Okay, so just depends on, in the program you're writing, are you using C strings or are you using string objects? Typically, you're going to be using string objects, and you're going to be using this version of getLine. Okay. Any questions about this getLine function? Yes, cin is an object, definitely, 100%. That's why you can put cin in front of the getLine too, right? We haven't talked about reading from any other place besides the console window, but we will be. And so that may seem a little odd, but you can always, if you want to read from a file in C++, all of the techniques are exactly the same, except where you see the word cin, you're just going to put a file object instead. Okay, so I would say getLine input file, comma name, for example. We'll be seeing more of that as we go along. Okay. Yeah, I mean, I hope I'm not surprised you forgot this. Not a bad thing, but let me just, my guess is you're not the only one, so let's talk about that for a second. Very first day of class, I said, maybe the second day, I don't know, cin hours worked. Okay, the action part of this statement from the first week of class is the extraction operator. This is an expression. There's an operator. The operator has two operands. Cin is the left operand, hours worked is the right operand. So the extraction operator says, take something from my left operand and put it into my right operand, right? So just a nice little review there. So same thing, we could say cin dot getLine C star 1. Right? That means read something from cin and put it into this variable C star. But this doesn't have to be cin. If I had an input file variable, I could just say input file dot getLine. Same thing here. Okay, I know we haven't stated input files yet. I'm just kind of giving you the idea that other things besides cin can go there. Okay, so in our latest version of getLine, sorry, the cin goes inside the parentheses as an argument. Right, the same thing. If we didn't want to read from the console window, if we wanted to read from a file instead, we could say something like input file string object. Right, cin is an object that is declared in the IOStream file. That's correct. Okay, all right, we are out of time. I think on Wednesday, we might just spend 5 minutes wrapping up this chapter on strings and characters and diving into our next topic. I'm kind of hoping to get through these next couple topics a little bit early so that we maybe have even a little extra time in case we need it to spend on object-oriented programming when we get to it. Any questions before we go? Sure, Trent, I'll stick around for a minute. All right, so that's all I have. I will see you all on Wednesday.